There's a view. This is a camera overlooking the exposed facility. So that's one of our fun facts. Both Chris Cassidy and Doug Hurley flew on STS-127, which delivered that facility to the International Space Station. They're just going to continue to close in those. So this will be their second time flying together. Chris hasn't flown with Bob Behnken before, but the two did transition the leadership role in the astronaut office, with Chris taking over from Bob once he was assigned to go off and begin training for these commercial crew flights.
Your screen now is a view of Dragon. You're starting to be able to distinguish the features a little bit more. The left side there, that semicircle, is actually the nose cone, and you can start to see the aerodynamic fins on the service section. Those small little blips at the top and bottom of the spacecraft. I'm sure these features are all going to get much, much better as we get closer and closer to station. We definitely had some spectacular views on the Demo-1 mission.
Yeah, we've been pretty fortunate. The outboard cameras catching Dragon when it was still several hundred kilometers away, which is pretty unusual for a visiting spacecraft. But right now it's continuing to close in. We're less than 10 kilometers from station, so just a little over 6 miles away, continuing to move towards that approach initiation burn. The target time that was just radioed up to the crew is about 5:11 a.m. Pacific, 12:11 Universal Time. And so we're going to be looking for that. And as Shiva said, we are inside integrated operations now. The teams here in Hawthorne working extremely closely with the teams in Houston. We heard all of those communications checks to establish the big loop. So all 4 of our major players in this operation, the ground teams both here in Hawthorne and in Houston, and our crew up in space, both on Dragon and the space station, all able to talk to each other and listen in simultaneously. So all of those bidirectional links have been established. The Dragon spacecraft communicating directly with the International Space Station at this point, and we are just coming up on a couple of minutes away, a little over 10 minutes away from that approach initiation burn. Cameras from station continuing to track Dragon. We are waiting for the confirmation from the crew on that suit of activity. They did start that a couple of minutes ago, and at this point we're about 7.5 minutes, or a little bit closer to 8 minutes at this point, away from that approach initiation burn.
Yeah, right now Dragon's flying actually over the South Atlantic, in between sort of South America and Africa, sort of over the ocean.
It looks like we're getting it in focus now. You can see the nose cone pointed to the bottom left corner. You can see it exposed right in the center, the smaller dark circle of Dragon. That's the docking ring that is going to be used to attach Dragon to that international docking adapter once it begins that final approach and initial contact.
And if you're trying to get your sense of bearings here, the nose cone actually opens away from the side hatch. So the hatch that Bob and Doug entered the spacecraft through on the crew access arm, and if you've had a chance to tune in to our live events with them on the capsule, they've shown that side hatch. That's on the opposite side of that nose cone. So you can imagine Bob and Doug and their seats are facing towards that side hatch. And so that's where they would be sitting once they're complete with suit donning and once they've stepped into those leak jets of their suits. The very top in that ring that Dan had mentioned, so along that ring are the 4 forward Draco thrusters. That's what we were using for those 5 burns that happened earlier over the past 16 hours of this mission. And right in the center there is the forward hatch. So hopefully only a few hours away from seeing Bob and Doug climb through that and aboard the International Space Station to meet their colleague Chris Cassidy aboard.
Yeah, just a couple of steps coming up after this approach initiation burn. They'll do what's called a mid-course burn, so just kind of a mid-course correction that's already programmed in. That comes about 25 minutes following the actual approach initiation burn itself. And then prior to them getting to waypoint 0, which is about 400 meters directly below the station, the teams will go ahead and do a go, no-go to enter the keep-out sphere. And again, that's that imaginary sphere with a radius of 200 meters around the station. They won't cross into that keep-out sphere until after their manual flight test when they're moving into waypoint number 2, but they'll do that go, no-go just before they're even at waypoint 0. And again, waypoint 0 could be a hold point, or if everything looks good with Dragon, they'll continue right on past it. So they'll swing up initially to that spot just 400 meters directly below station, and then they'll conduct another maneuver to go right out in front of station. So they'll go right up in front and line Dragon pointed directly back at the station itself and lined up with that hatch.
Yeah, and once they get to that 220 meter point, you'd mentioned the manual flight test that they're going to do. The Dragon spacecraft can approach completely autonomously, but of course the crew aboard, and actually the crew aboard the crew aboard Dragon can issue manual piloting commands and control the translation if they needed to step in, or issue commands to have Dragon retreat or break out from its approach. And the crew aboard station as well can issue commands to Dragon. That's part of what Chris Cassidy aboard station will be monitoring as they approach. If you want to give your chance at trying to fly the spacecraft, we actually have a cool simulation on our website. It's iss-sim.spacex.com, and you can actually fly pretty much the display that Bob and Doug will be flying when they do that translational test. It's a little bit difficult. I definitely didn't dock the first time I tried it. I don't know if you had better luck, Dan.
No, I could lie and tell you I did, but it did take me 3 tries. I think I made the same mistake as everybody. That first try just ended up going in way too fast. That second try tried to over-adjust, and all of a sudden I was spinning backwards. And you really learn that just the tiniest adjustments when you're in a spacecraft and you're flying in microgravity can have a really big effect on the vehicle. And you just kind of have, if you start to turn left, you need to turn right just to make sure you kind of null it out or stop that motion. Otherwise, you're just going to keep on going. Same thing as when you're doing that approach. You have to slow down. There are very slow speeds that are acceptable for the docking. They'll be going right around 1/10 of a meter per second when they make that initial contact and capture, so extremely slow. If you're doing the simulator, you can pick up speed pretty quick, and then you have to start slowing down pretty quick because you'll move in, and you have to constantly be thinking about all of the different...
SpaceX Dragon, comm check from the CDR in suit.
And this is SpaceX on Big Loop. I hear CDR loud and clear. Help me.
Dragon on the big loop, com check suited. We've got you loud and clear on the big loop.
Great to hear your voice.
All right, that was Doug Hurley. It sounds like they're in their suits. You heard him refer to CDR, Doug Hurley, the spacecraft commander for this mission. Bob Behnken's in the pilot seat. He's also the Joint Operations Commander. And so this is actually one of the main areas of his concern is when we're doing these joint operations with the space station. So we're doing joint operations here on the ground. That obviously just means that the Dragon spacecraft and the International Space Station, close proximity and about to be linked up. Bob Behnken, the one kind of overseeing all of the operations while Dragon is attached.
Wow. Well, that is a very pretty view.
Yeah, getting a view of Dragon. We're coming up pretty soon on that approach initiation burn. Dragon itself is inside that 7.5 kilometer range that we're expecting it to be away from the space station before this starts. And we did hear confirmation that the AI burn, the approach initiation burn, is in progress. Again, this is about a 90-second firing of those thrusters on the Dragon spacecraft.
Dragon SpaceX on big loop, burn complete, nominal burn. Reminder to review your impulsive retreat recovery cue cards if desired.
Copy nominal burn on the big loop. We will review our cue cards.
So Anna Menon, the Corps there, giving the crew some insight that the burn was completed nominally. As Dan had mentioned, there is that mid-course correction. And Anna had mentioned impulsive retreat cue cards. Bob and Doug have the ability to issue commands to Dragon if they see anything that's unsafe. So, of course, on those 3 displays that they have between the 2 of them, they can see the rate of the vehicle, how quickly they're closing, and they have a set of criteria that they're looking for to make sure that they're safely approaching the station. So Anna just giving them a heads up that they should review that criteria if they so desire, so they feel fully confident before the mid-course.
And here's a really cool view. So on the right is a view from station looking at Dragon. On the left, a view from that camera, that thermal camera on Dragon looking back at station. So it's continuing to close in. It's about 6.5 kilometers or just over 4 miles away. That AI burn, that approach initiation burn, was done successfully, reported up to the crew and the teams down here on the ground. They're going to do a mid-course burn, so just about midway through their track up to 400 meters below the space station. That'll come in about 23 minutes from now. And then we're waiting until we get to waypoint 0. It should take about 43 minutes for this kind of gentle glide from 2.5 kilometers below to just 400 meters below. That'll take about 43 minutes until they arrive there.
Yeah, and if we hopefully have a good video of Dragon during that mid-course correction, you may see some small plumes coming off of the sides of the vehicle. That's those 12 service section Draco thrusters doing small attitude adjustments, just to make sure that we're coming to station as expected. Really small, minute corrections at this point. Kind of fun to see the
Dragon SpaceX on Dragon to ground, just checking for a status on suit donning.
You're welcome to come back on board. We're both in our suits, and we're just finishing up the procedure now.
Copy, thank you. And can I get a comm check with Bob when he has a moment, please?
About to do that, maybe a minute or so.
Okay, sounds good.
So Bob and Doug finishing up their suit donning. At this point in their procedure, they will be seated in their suits. The feet of their suits actually have restraints that clip into the footrests. And so once they are complete with all their suit donning activities, seated in the suits, then they'll be ready to work with SpaceX to do a pressure check on those on those IVA suits. That's intravehicular activity suits. And cool thing actually about the suits, so that the helmet is 3D printed, and the mics that they're doing their comm checks on are integrated into the body of the helmet. So all part of integrated design, and the suits have a single quick disconnect umbilical, as you might hear it called, that actually carries the either nitrox or oxygen, depending on the cabin pressure state, and the comm signals to and from the suits.
Yeah, and they're going to be in these suits through the duration of this docking procedure. Again, they're always just donning those suits for anything we consider kind of a dynamic operation. So obviously, they'll launch an ascent, the docking and undocking from the space station, and they'll be back in them when it's time for deorbit and landing at the end of their mission. Right now, though, Dragon in station flying 260 statute miles over Nigeria. They're about to make a pass right over the central and northern parts of Africa and over the Sahara Desert. We're past the approach initiation burn that was done successfully. They'll do a mid-course burn in a little under 20 minutes from now. We're still about 40 minutes away from the arrival at waypoint 0. So at that point, Dragon will be exactly 400 meters directly beneath the International Space Station. On the way uphill, we're going to listen in for the teams in mission control.
Dragon SpaceX on Dragon to ground. Friendly reminder to please unlatch the toilet button before you get back in your seat.
Okay, we'll unlatch the toilet button.
Thank you.
Well, you know, as they mentioned earlier, it is a lived-in spacecraft. So, of course, as part of the life support system, you have to take care of those things about being human.
For now, we're just keeping our eye on Dragon during this approach. It's in the approach initiation. Our next thing coming up is going to be that mid-course burn coming in just a little over 18 minutes. We're a little under 38.5 minutes away from the arrival at waypoint 0. That's going to be the first of 3 waypoints on our way to a docking today. Again, we were targeting about 7:30 a.m. over here on the West Coast for that docking. We might get there a little bit early as they have been moving through a couple of these steps. We were able to do that approach initiation burn about 16 minutes ahead of the original timeline. So we might get it a little bit early on the docking today. We do have a number of different steps, including a manual flight test, so it'll all depend on how that goes. But progressing smoothly. We may pause at waypoint 0. We may continue right along if everything's looking good with Dragon, and then they'll be able to move over to waypoint 1, which will place them just 220 meters away from the station.
Yeah, and earlier we were talking about how gentle a lot of these movements are. Small thrusts, small corrections, because you do really want to be very controlled as you're approaching the space station. There are a couple of maneuvers, though, if Dragon were to detect something, or if the ground teams, or if the crew were to detect something, where they could do what's called a breakout maneuver, which is very dynamic. And that's part of the reason why we have them in the suits. That's part of the reason why they're going to be strapped in. If something were to be detected that was off nominal, that could be a risk there. That's always a possibility. Of course, we're not expecting that. We are expecting Bob and Doug to exercise the hold functionality just outside waypoint 1 to do the manual piloting test.
And after that test is complete, they'll hand control back over to the Dragon spacecraft. It will resume its automated approach to the International Space Station. They'll move into the final waypoint, waypoint number 2, at which point they'll only be 20 meters away from station. And there we will have an automated hold where the teams will do a final go, no go, just to push in for that final approach and docking. They'll move in pretty slowly, and then just seconds before docking, a little less than 30 seconds before, we may hear the call out for CHOP. That stands for the crew hands-off point. And this is literally just the point where the crew will not be sending any commands to the vehicle. It's all over to Dragon if any aborts need to be called, just due to the latency with the flight computer responding to crew actions at that point. And then we'll stand by for the contact and capture. Again, we were tracking
SpaceX Dragon from the PLT comm check. Dragon to ground.
I hear you loud and clear. Help me.
Loud and clear, Anna, and Doug and I have a good intercom check as well.
Copy. Good intercom checks. Let us know when you are done with that full suit donning procedure, and we'll bring you into suit leak checks.
So Bob Benkin hopping on the comms there. He used the acronym, or I guess the letters PLT for pilot.
Okay, we're donning our gloves at this time.
We copy.
So for ISS missions for NASA, there are 4 seats in the Dragon spacecraft. If you were looking in from the side hatch, it would be seat 1 on the far right, all the way counting up to seat 4 on the far left. Doug Hurley in the commander or CDR seat. That's seat number 2. So it would be the second seat from the window.
Right.
Yeah, second from the right.
It goes backwards from the way we're normally taught to read. And so it is a little bit confusing when you're looking at it, unless you're in the crew's point of view, and then it makes sense because you're going left to right, 1 to 4.
And Bob Benkin in the pilot seat right next to him. It's second from the left. And in front of them are those 3 displays and the button panel that we got a chance to see earlier that they'll be monitoring telemetry on and using to exercise that manual piloting test.
And it looks like the crew just has a couple of steps left until they're done getting into their suits, and then they'll go ahead and do another leak check. This will be the 3rd leak check they've done in these suits since their day started yesterday. They did an initial one when they got suited up in the operations and checkout facility down on the ground in Kennedy Space Center.
SpaceX Dragon on Dragon to ground. We're complete in 4.010.
Copy, complete with 4.010 for suit donning. At this point, you are go to begin your suit leak check procedure.
We'll put 4.011 in work.
And so with that, the crew are going to step into leak checks again. This is going to be their third one. They've already done one when they initially got suited up in the operations and checkout facility, another one once they climbed into Dragon when it was still on the pad and connected their suits via umbilical to the seats in the Dragon spacecraft.
SpaceX Dragon in 2.2, we are ready to pressurize.
And Dragon SpaceX on Dragon to ground, you are go to pressurize.
Okay, visors are down. We'll put that in work.
So now the crew are going to step through and pressurize. Normally when the suits aren't pressurized, they can keep one of the zippers kind of just cracked open, and they're able to just flow cabin air through the spacesuit itself just to provide some cooling while they're inside. We can either flow nitrox into the suits. You could do that if you had a contaminated environment on board the Dragon spacecraft. It's something we also look for on the space station, and they had some air samplers out a little bit earlier, just looking for any trace contaminants in their breathing atmosphere. The suits also can have pure oxygen flown to them or flowed to them should the cabin itself depressurize. That'll happen below a certain PSI threshold, as we don't pressurize the suit all the way up to 14.7 psi if we're in a depressurized environment. Otherwise, you would be in essentially a pretty big balloon, and it'd be really hard to move. So they pressurize it to a much lower threshold, and just to make up for the lack of oxygen, therefore in a lower density air, you'd be flowing them pure oxygen. So those suits just serving as another barrier protection for the crew for anything like a contaminated atmosphere or a depressurized cabin inside Dragon. But crew suited up now. Sounds like we're about to step through these leak checks.
Yeah, and we were talking a little bit there. So as you're listening to comms, there's some call outs for 4.010 and 4.011. Those are referring to procedures that the crew have on the spacecraft. So they have procedures built into their displays. These two just happen to be the two that they're running right now. They also have those on their tablets, so they can follow along there if they needed to. We were also talking a little bit about 14.7 psi. I know you and I both have engineering backgrounds, but if you don't have an engineering background, the atmospheric pressure at roughly sea level, sometimes referred to as 1 atmosphere, is roughly about 14.68 to 14.7 psi. So if you're at sea level right now, or pretty close to, what you're walking around in is 14 pounds per square inch of force about on your body. And that's roughly what the Dragon capsule is also at when they're flying up.
And while those leak checks are in work, the station itself is in the docking attitude. We get to do a pretty cool thing with station during the docking of the Crew Dragon. Normally, the station's attitude, or which way it's pointing, is controlled by these very large gyroscopes called control moment gyros. And it's a pretty efficient way, only using electricity, to keep these large gyros spinning, pointing in opposite directions to help stabilize the station. It's a very large spacecraft. So using thrusters a little more work intensive. We actually switch over to the Russian thrusters during the initial docking of the Dragon spacecraft, and then after that.
SpaceX Dragon on Dragon to ground, we saw 2 good leak checks.
And Dragon SpaceX on Dragon to ground, we saw the same. Great news, thanks.
And we just got confirmation 2 good leak checks on those suits, so another milestone down as they continue their approach. But just to finish that thought, we're on Russian thrusters right now, controlling the attitude on board the space station. We'll flip over back to the control moment gyros, so those are over on the U.S. segment once we make that initial soft capture, just because we don't want, during that final pull in of that soft capture ring before we get to that ready to latch. The thruster controls of the Attitude can be a little bit more jarring, so we switch back over to the control moment gyros and then let Dragon resume its hard mate. But all that coming up in just about 2 hours, hopefully, away from our targeted docking time, right around 7:30 a.m. Pacific here in Hawthorne. But everything continuing to go well. We had that approach initiation burn happen about 16 minutes ahead of schedule. In just under 8 minutes from now, we'll do our mid-course burn, and then we're standing by for that arrival at waypoint 0 in just under 28 minutes from now.
Now on your screen is a view of the Dragon spacecraft from the International Space Station. We're on the sunlit side of the Earth, so daytime for those folks. Middle of the day, I'm sure. Right now, actually, Dragon is just about to fly over the Caspian Sea. So if the clouds sort of break a little bit, we might get some cool views of planet Earth behind us. You know, once that suit lead check is complete, Bob and Doug might pop open their visors. Those can come open for their comfort. So you may hear some calls about that coming up here.
Right now, Dragon just continuing to close its way in. Right now, we're about 2.5 kilometers away from the station, so just a little over 1.5 miles, closing in at a rate of about 3 meters per second, or about 6.7 miles per hour. The Kronos flight controller over in Houston, controlling this camera outside the station. He's controlling it from that mission control center on the ground, giving us a nice zoomed out view as the Dragon spacecraft and the International Space Station actually just flying over Kazakhstan. They are a few hundred miles to the west right now of Baikonur, which until yesterday has been the only gateway to orbit for our U.S. crew members to the International Space Station. So they're going to make a pass just to the north of Baikonur. We're looking at Kazakhstan in the background, but with this, a U.S. vehicle launched on a U.S. rocket from U.S. soil, now in the mix, a new era and a new path to station for our NASA crew members.
That's right. Actually, Chris Cassidy would have blasted off out of Baikonur not that long ago on a Soyuz vehicle. So he would have been launching from right where the crew are flying over right now.
But everything's still looking smooth with their trip up to station. We're about 4.5 minutes away from that mid-course burn. We should be arriving at waypoint 0, which we may pause at, we may go right past, depending on how all the Dragon systems are looking for the teams down here on the ground in Hawthorne and the team over in Mission Control Houston. We'll get to that waypoint 0 at about 24 minutes from now, and then continue on to waypoint 1, at which point we'll watch Dragon go from the bottom of the station, where it's going to be on what's known as the R bar, or the radial vector. That's if you drew a line straight through the International Space Station down to planet Earth. Dragon's going to be pausing or going right through 400 meters on that line, and then it's going to swing itself up out in front and align itself with the docking adapter on the Node 2 forward port, and they're going to pause at about 220 meters away from the station.
Yeah, right now Dragon is in a pointing mode that has it and its variety of guidance and navigation control sensors pointed directly at the station. Earlier on in the webcast, we actually got a few glimpses, I think, thermal images of the International Space Station. So we had a cool side-by-side of the space station and Dragon next to each other, views relative to each other. So those sensors are pointed at the station right now. Right now, Dragon's attitude control system is trying to maintain its attitude, null out any sort of roll or any sort of motion that it might pick up from just as it's flying towards the station. That's part of the reason we've had those great views looking at the forward hatch and where we can see the nose cone. Right now, that's that little dark dot at the bottom of your screen. You can see it highlighted against the clouds as we're flying over the middle of, it might be over Russia, I think, right now. Unfortunately, my ground trek map does not tell me all of the country labels, so.
It looks like we're still over Kazakhstan. We should be over Russia for a short little bit in a few minutes, and then they'll fly out over northern Mongolia, continue down, flying over northeastern China, make a pass over the Korean Peninsula, out over Japan, and by that point, they'll be in an orbital nighttime. So moving pretty quickly, a little over 17,000 miles an hour. But relative to each other, their speeds are pretty close. Dragon's only moving in at a rate of about 2.4 meters per second right now. So we're a little under 1,800 meters away from the space station at this point, standing by for that mid-course burn. And at this rate, we're going to get to waypoint 0, so just 400 meters below the station in just under 22 minutes.
Yeah, and we talked about the approach ellipsoid and the keep-out sphere a little bit earlier, but around the space station, there's a 4 kilometer by 2 kilometer by 2 kilometer ellipse. It's an imaginary shape around the space station, which is designed to help vehicles make sure that they're staying clear of the station unless they have business to conduct, which of course the Demo-2 mission does today with docking at the station. So being 400 meters below along the R bar, as Dan had mentioned earlier, will be well within that approach ellipsoid, but not quite within the 200 meter keep-out sphere around the station. So that'll happen when we get just past waypoint 1, which is waypoint 1 is at that 220 meters away from station there.
Yeah, and Dragon at this very moment only a mile away from the International Space Station. So it's continuing to close in. We should be just seconds away from the start of that mid-course burn. This just to help fine-tune its path up towards waypoint 1. Or waypoint 0 rather, just 400 meters below the space station, which we'll get there in about 20 minutes. About halfway there, though, the teams will do a go, no go if they're just going to pass waypoint 1 and then move on to, they'll go past waypoint 0 onto waypoint 1. Try to keep everything lined up here for you, not to confuse you. We'll have 3 waypoints. It'll be waypoint 0, 400 meters below the station, waypoint 1, 220 meters out in front of the International Space Station, and then waypoint 2, just 20 meters in front of that docking port on the Node 2 forward port. And so we're going to move through all of those quickly. We should be in the mid-course burn at this point. And so Dragon just doing a slight adjustment as it continues to swing up. It's eventually going to be just 400 meters directly below the International Space Station. Bob and Doug strapped into their seats, suited up, along for the ride for now, as this is automated, but we won't be automated the whole way since this is a demo flight.
Yeah, and actually on the screen to our, I guess, on the right side of your screen, there you saw some orange blips that represents the service section Draco engines firing. So there are 12 of those on the service section or the trunk of the vehicle. And once we get through this mid-course maneuver, we'll probably hear some words from the Corps to Bob and Doug, letting them know.
That's right, and we do have confirmation that the AI mid-course or the approach initiation mid-course burn is underway. Again, we expect this one to last just a little over a minute. And this is, again, just to really fine-tune that approach.
Yeah, all of these maneuvers are pretty small at this point.
Dragon SpaceX on big loop, burn complete, nominal burn. Trajectory has converged on waypoint 0.
I can copy, nominal burn.
There's those two words, nominal burn. So we won't have any more significant burns. We're still going to be using those engines, obviously, for the final approach maneuvers. But at this point, Dragon now approaching waypoint 0.
Yeah, and really at this point, it's all relative maneuvers, a very slow and steady approach to the station. Of course, that small translational test with Bob and Doug commanding Dragon to do some small manual piloting maneuvers.
Things are going to start to darken, but hopefully we'll still be able to keep Dragon in view as they are crossing pretty soon into an orbital nighttime. At this moment, we're less than a mile away from station. Dragon just under 1,200 meters away, continuing to close the gap. Pretty slow rate right now, moving in at only about 1.7 meters per second. We're going to be standing by. There's going to be an internal go-no-go poll about passing waypoint 0. That should be coming up in about 7 minutes. We'll continue to listen in with the teams. We're expecting Dragon's arrival at waypoint 0, which we heard its trajectory has converged on. So that means Dragon pointed in the right direction on its way to that waypoint just 400 meters below the space station.
Yeah, and to maybe put that 1.7 meters meters per second in perspective, if there are any runners or joggers listening, that's a pretty reasonable pace jog. So right now, the spacecraft is moving towards the ISS about as fast as if you were going on a morning jog.
All right, so at this point, we're inside the approach ellipsoid that we were talking about. So as Dragon moves inside of just about 1 kilometer away, again, the approach ellipsoid is an elliptical shape, 4 kilometers long by 2 kilometers tall by 2 kilometers wide, essentially a 3-dimensional oval. And that's just one of those checkpoints around the station that governs the approach of visiting vehicles. Before we were in this point, Dragon was on a 24-hour free safe trajectory. So if we had lost control of Dragon, it would have been at least 24 hours before we moved inside. But we're now inside this approach ellipsoid. Dragon given the go as it was given the authority to do the approach initiation burn. And so that next imaginary gateway around the space station is the keep out sphere. That one's a little bit smaller, has a radius of only 200 meters, and we won't be crossing that until we're done with the manual flight test, but we'll do the go, no go to cross that sphere well in advance of them actually moving in.
Yeah, in about 14 minutes from now, there'll be a small correction maneuver to take us from waypoint 0 to waypoint 1 right outside the keep out sphere. So if we have a video of Dragon at that point, you may see the Draco thrusters firing. Right now, vehicle looking healthy as it's making its way towards that R-bar approach, just 400 meters below the International Space Station.
Pretty
So we're
dramatic
coming-
shot of Dragon as it continues to close in. The station and Dragon right now just over the northeastern part of China. They are in an orbital nighttime, so the sun is setting on both vehicles right now as they're flying about 262 statute miles over the surface of planet Earth. 2 crew members, NASA's Bob Behnken and Doug Hurley, inside Dragon, closing in on their home for the next several months, and completing the first crewed flight of the commercial crew program era to the International Space Station. So we should be under 2 hours away from the planned docking time. We were looking at a docking around 7:30 a.m. Over here on the West Coast, but they were able to move through a number of their maneuvers a little bit quicker. We've got about 16 minutes ahead of the approach initiation burn, so that docking time will be a little bit variable and will hinge on how quickly they're able to move through that second manual flight test. But everything continuing to go smoothly. We're waiting for their arrival at waypoint 0. Should be coming up in just about 12 minutes from now. All right, so we heard both teams, the NASA and SpaceX teams, are go to continue on past waypoint 0. So they'll be coming up on that point in about 10 minutes from now, and they're just going to continue on along up until waypoint 1. And so it'll be a quick pass through. They'll go from just 400 meters directly below the International Space Station up to waypoint 1. So they're going to do pretty much a 90-degree maneuver to go from directly below station to directly in front of it. And this is always something really cool to see. So you're seeing city lights on the ground below Dragon right now as we continue to fly. We just made a pass over Japan. So those were city lights in Japan as Dragon and the station just made a pass over, and now they're about to cross over the northern Pacific Ocean. So things will be dark for a little while as Dragon continues to close in. We should have sunrise coming up at about 21 minutes after the hour. So if everything holds on track, we should have some good sunlight for docking, hopefully, but we'll have lights on board the Dragon itself. You can see the red and the green telling us where it is as it continues to approach. At this moment, we are just about 585 meters away. All right, in just about 8 minutes, we're going to pass through waypoint 0 and continue on to waypoint 1. And then shortly after that, the crew's going to get their second chance to jump in and start sending some commands to Dragon.
That's right. On the displays, they have some commands in the upper right-hand corner. We got a little sneak peek at that while they did one of their video sessions showing us the displays earlier in this mission. And they'll command a hold once they get to about 220 meters away from the station. That's where they'll conduct that manual piloting test.
And again, this will be their second manual piloting of the Dragon spacecraft. We were able to watch them yesterday.
Copy that. Be ready.
Yesterday, shortly after getting on orbit, they were able to take control of Dragon and go through a number of pointing maneuvers or attitude adjustments. And in this case, they're going to be doing pretty much the second half of everything. When you're flying a spacecraft, you're worrying about attitude adjustments, and then you're worrying about translational adjustments. And this is going to be their chance to do those translational maneuvers.
Yeah, and once they finish that manual piloting test, then Dragon will take over. They'll transition and go towards waypoint 2. That'll put them just 20 meters away from space station.
All right, well, as we're just about 5.5 minutes to their arrival and quick pass through waypoint 0, let's jump over to Gary Jordan over at Mission Control Houston to check how everything's lining up with the teams in Houston for this approach and docking. Gary?
Thanks, Dan. Really good to see Dragon, Bob, and Doug inside of 500 meters, so close to the International Space Station, just flying through all of the milestones we have to get towards docking towards the International Space Station. A lot of prep work went into this moment. Just previously, we transitioned control of the station's attitude to Russian thrusters, also configured the station itself for the docking attitude. Chris Cassidy was just finishing up his midday meal. His next activity, just a little bit more than 20 minutes from now, will begin to set up for Dragon monitoring. He has a tool called the RPOP. We'll be able to display some of the telemetry data coming from Dragon through the C2V2. This is the common communication for visiting vehicles. It's established a link between the International Space Station and Dragon. Dragon's telemetry data, all the information being relayed through the International Space Station. And Cassidy will be able to monitor from this tool, again, setting up in just about 20 minutes. Everything going according to plan from the International Space Station side of things, getting great views from Dragon of the International Space Station. Look at that, the lights reflecting from the outside of the International Space Station turned on. So Bob and Doug have a very clear view of the International Space Station. Should be entering into an orbital sunrise here shortly. From there, we'll take you through the next few maneuvers, again, passing waypoint 1 and going right into that manual flight test. Again, everything here from Mission Control Houston, International Space Station configured for docking. Everything's go from our end. Back over to you in Hawthorne.
All right, thanks, Gary. We're jumping in now with Bob and Doug inside the Crew Dragon. Again, you're able to see what they're looking at on those displays there. And this a view from the Dragon spacecraft itself. You can see the International Space Station continuing to close in. Right now, they're only about 430 meters away. They're going to be quickly passing through waypoint 0 in the next 3 minutes, and they're going to continue their way up to waypoint number 1, which is going to be just about 220 meters out in front of the station itself.
Yeah, and Dragon has a number of relative navigation sensors, items that are used for guidance and control of the vehicle. So right now, Dragon's in a pointing mode that has those relative navigation sensors trained on the space station, with the attitude control system making minor adjustments as it needs to, if there's any roll correction or anything that it needs to perform. And Bob and Doug getting closer and closer to that manual flight test. They looked pretty comfy in those seats for that view right behind them.
Yeah, they are suited up, and again, they get suited up for anything we consider kind of the dynamic operations inside the spacecraft. So anytime that they're either in an approach and docking maneuver or an undocking maneuver, and then obviously at the very start and the very end of their missions, which are probably the most dynamic phases, that launch and ascent, and then that deorbit and splashdown when they come home and splash down in the Atlantic. We are just 420 meters away from the space station, less than a third of a mile. Should be just about a minute and a half until we're passing through waypoint 0, and then Dragon's going to begin a little over 20-minute, about the 25-minute trip up to the docking axis. So this will be waypoint 1. They'll be 220 meters directly in front of the station, and they'll be lined up perfectly with that international docking adapter at the very forward port of the Node 2 module, also known as Harmony, on the space station.
Yeah, and there'll be a small attitude correction there. The navigation and prop specialists on our team will monitor that burn. Then hopefully we'll hear some words from the Corps to the crew letting them know that we've had a good course correction towards waypoint 1.
And again, things a little bit dark right now. We should have sunrise in about 25 minutes. And so things will light up as we get closer to that manual flight test, and hopefully by the time we're there, we'll be right in front of the space station itself. We should get some good light on Dragon, and hopefully some views from the station looking straight out at the spacecraft using the cameras that are right next to that docking port on Node 2. And then Bob and Doug will once again take the controls using those touchscreens to maneuver Dragon. They'll do a number of different translational maneuvers, so physically moving the Dragon spacecraft in space. Oh, we're seeing some thruster firings there. And so those are using some of those, we call them the service section Draco thrusters. There's 12 around the lower part of the Dragon spacecraft.
So if you're just joining us.
Station Houston on the big loop for Chris. Dragon's now transmitting docking camera video. We want to confirm that video and data is updating in the Dragon 2 docking monitor.
Work. Confirm.
Copy, confirmed, thanks.
So as I was mentioning earlier, if you're just now joining us, Dragon is now just 220 meters in front of the space station. The astronauts aboard, Bob Behnken and Doug Hurley, have commanded a manual hold. That's to perform a manual piloting test. There is a very nice shot of the Dragon vehicle from cameras aboard the space station. You just saw one of the Draco thrusters there firing, just to keep it in that hold attitude, flying right in front of the station.
Yeah, we have two cameras on the very forward port of Node 2, so right where Dragon's going to be headed following the completion of this manual piloting test.
Dragon SpaceX on Big Loop. C2V2 link reconfiguration is complete. The soft capture ring extension is also complete.
Dragon copies on the Big Loop. Good ring extension and C2V2 reconfig.
So those comms on the Big Loop, the core, the crew operations and resources engineer here at SpaceX letting the crew know that we have a good TDRS link again. Good C2V2 link again. It's common communications for visiting vehicles. And we actually heard a little bit earlier as well comms to Chris Cassidy to monitor this manual piloting test.
Dragon SpaceX on Big Loop, you are go to execute the proximity manual flight test per procedure 4.041, and I have the target fuel levels when you are ready to copy.
Copy, we're go for 4.041, and we're ready to copy the fuel constraint.
Your 1/3 fuel usage will be 60.9, 2/3 58.9, and terminate 57.9.
We copy 60.9, 58.9, and 57.9. We'll pick up in 4.041.
Good copy, and we're with you.
All right, so they're going to start maneuvering Dragon, again, making some translational maneuvers. We did get some insight that it looks like they're a little bit to the left of the docking axis right now. And so we should expect them to move directly into the center line as one of their first maneuvers. That's going to be their very first maneuver. And then they have a strict list of choreographed steps just to test out moving on the other axes. And we heard the Corps Anna Menon calling up the expected fuel usage inside Dragon. They're going to be keeping a close eye on that just to make sure they're not overusing the propellant in those flight tests, making sure we still have good margins for all of the approach maneuvers and then obviously for everything at the end of the mission itself.
Yeah, and the thrusters that we're using here.
Dragon, on the big loop, we are commencing with docking axis capture.
We are following along with you.
So the thrusters that we expect to see firing here would be on the service section or on the trunk. And you'll see some plumes coming out from the shot on your screen.
First part of this maneuver is just to really line them up perfectly with that docking axis. So they were already several meters off once this hold occurred, and so they're making very low impulse commands being sent to those Draco thrusters. Again, as Shiva was saying, there's the 12 around the lower part of the Dragon capsule that they're going to be using. We're seeing small bursts now.
Yeah, and they actually have a couple of precision modes where they can put in sort of coarse and fine inputs into the vehicle. That's all stuff that they can control off of those touchscreen displays to get the right amount of impulsive thrust into the vehicle. If you're trying to get a little bit oriented to how the vehicle is positioned, that's the nose cone on the top of your screen. So Bob and Doug would be sitting sort of underneath that nose cone and see the pressurized portion of the capsule, and their seats look up into the displays and also would look towards the side hatch, which is currently sealed underneath on the opposite side of where that nose cone is. Very cool to see those thruster plumes.
Yeah, the Kronos emission control Houston actually opened up the iris a little bit on that camera on the space station so we could see these plumes.
And SpaceX Dragon, we've completed the docking axis capture maneuver. We're going to move on to the YZ translation.
Copy, we're with you.
All right, sounds like they've got themselves lined up exactly on the docking axis, so directly in front of that international docking adapter on Node 2. Now they're going to begin some lateral and axial maneuvers. So again, just putting Dragon now off the docking axis, and to just continue these translational maneuvers. So at this point, we should see them head up to the right and up from this view, as they're just making very small adjustments in the Dragon's positioning in front of the space station right now.
And here comes the translation.
We copy.
Yeah, in the data, it looks like we're seeing the 6 thrusters essentially on the bottom of the spacecraft right now from this view, lighting up. So it's going to begin to move them straight up. And it's difficult to tell, but there is a very slow drift upward right now.
Yeah, it looks like they're going about 0.1 meters a second, if I'm looking at this data correctly. So very slow and steady. And they will probably do a quick correction to stop that upward movement. It's a little surreal seeing Dragon so close to the space station. You know, less than 18 hours ago, I was on the pad at Launch Complex 39A. Now it's so close to its destination.
Yeah, being piloted by humans for the 2nd time already in this mission.
And I would just be too excited. I don't know how Bob and Doug keep this so professional.
It's that test pilot mentality.
Yeah, they both have thousands of hours in aircraft. Both test pilots.
Yeah, both came from military test pilot backgrounds. Bob Bank in the Air Force, Doug Hurley, a Marine Corps aviator.
And then I believe Naval Test Pilot School, so... A little bit overexposed there, but you can still see the thrusters firing.
Yeah, our Kronos working to do that deliberately for us so we can see those thruster plumes from this camera view. We're at a normal exposure, so not able to see those jets into the darkness of space. But when we do overexpose a little bit, you're able to see those thruster plumes coming out of the Dragon spacecraft.
Yeah, it's amazing how the plume has to catch the light just the right way for us to even see that it's happening outside of data. Yeah, and looking at the data now, it looks like we have zeroed out that that radial velocity delta. So Bob and Doug cleared out that small translation test that they did. We may get a radio call down here that they've completed the Y direction testing. Now, I know we've mentioned this a few times, but it looks like the spacecraft are totally still right now. And that's partially true. They're still relative to each other. But right now, both the space station and Dragon are going around the world, what is it, about once every 90-ish minutes or less?
Once every 90 minutes, seeing 16 sunrises and sunsets every single day. And while our view right now,
We've completed the Z translation, moving on to the Y.
We copy. We're with you.
I copy. So I was a little bit mistaken. They just finished up the Z direction, doing the Y next.
Dragon, SpaceX on Big Loop, you have used approximately 1/3 of your prop test budget.
And Dragon copies 1/3 of the prop test budget.
So the Corps letting the crew know how much prop they've worked through. Still have 2/3 of their budget left to do test maneuvers. And of course, any bit of propellant that they're using is just a little bit less margin if they needed to use it for something else. But a good way to exercise the system, see that manual piloting works as intended, and I'm sure for them to have a chance to provide some feedback on how manual piloting actually felt in space and how the control felt.
yeah, a big part of their job for this mission is really to not only put the vehicle through its paces, but to take a lot of detailed notes and mental notes that they're going to be passing along to any future crew members flying on board Crew Dragon. As we've talked about, the simulators have been a pretty good guide for how the actual manual piloting goes, but things like the ascent up to orbit were quite a bit different from what they expected. And so they're just taking all of that in, internalizing it, and a big part of their job once they come home is to pass that along to all of our upcoming crews, one of which is targeted to launch just about a month after they come home. That Crew 1, the outfit of 3 NASA astronauts, Victor Glover, Mike Hopkins, and Shannon Walker, and a Japanese astronaut, Soichi Noguchi, will be aiming to do that flight a little bit later this year. So going through the paces right now, looking at our data, I think I made the same mistake you did, where I assumed them going up would be the y-axis. It looks like that was actually their z-axis, and the y now them moving to the right. So we're seeing some small shifts. They're continuing to use up a little bit of their prop budget. We heard they're already a little past 1/3.
Yeah, it's actually something interesting about both aircraft and rockets. When you consider the coordinate system, what we refer to as the x-axis is usually the one that goes through the nose. So in the case of Falcon 9 and Dragon sitting on top of each other, the x-axis would have been pointing through the nose cone going up. Can be a little bit counterintuitive. And then actually in aircraft, the z-axis usually points down, depending on whether you use European or American coordinate systems and the type of aircraft you're working on. But important for both space station and Dragon to be on the same coordinate system as they do this eventually, as they step into the approach maneuvers here towards waypoint 2, Dragon will be using its relative navigation sensors, again, for relative position to the station, to make sure that it's on the approach, within the bounds of the approach corridor going towards the station when we get to that after this manual piloting test.
Should be getting to that shortly. This manual piloting test was slated to last about 25 minutes. And as we have been running ahead of schedule today, with all of Dragon's maneuvers, we could be looking at a docking only about 25 or 30 minutes from now. So once they're done with this manual flight test, they'll turn control back over to Dragon's flight computers, and they'll resume their approach, which had actually already started automatically before the crew issued a hold command to the vehicle. And then they'll press in to arrive at waypoint number 2, at which point the teams will do a final go, no-go for docking. They'll depart that 20-meter hold point, and it should be just about 5 minutes following that departure until we get contact and captured.
Yeah, and the crew right now are seated in Dragon in the pilot and commander's seat. Both of them are suited for what are relatively dynamic maneuvers, and they'll continue to be suited until we have confirmation of good hard capture on the space station. So right now, just interfacing with the touchscreen displays, testing out manual piloting. Hopefully secretly a little bit giddy to be piloting a spacecraft.
I mean, before they had launched, Bob Behnken had referred to this mission as every astronaut's dream, getting to launch in a new spacecraft, putting it through its paces. He and Doug Hurley, with those test pilot backgrounds, testing out a new spacecraft has to be as good as it gets. But they're still stepping through this manual piloting. We should have just a few more minutes until they're done with this Y-axis translation. And then they'll be able to turn command back over to Dragon, which will return itself to the docking axis and then begin that approach into waypoint 2.
Yeah, and as a look ahead, so when we do transition into that approach, Dragon will autonomously go towards waypoint 2, which is just 20 meters away from the forward international docking adapter on node 2. And it'll hold there. That'll give the ground team some time, both in Houston and here in Hawthorne, to do a go, no-go poll, make sure that the vehicle still looks healthy, make sure that everyone on board the space station and of course on board Dragon.
SpaceX Dragon, we've completed with the translation maneuvers. We're going to pick up with the closure maneuver.
We copy. We're following along with you.
All right, sounds like they're done with their translations. They're going to start moving it back to the docking axis, put us right back on the center line, and then we're going to resume that approach into station.
Dragon SpaceX, you have used 2/3 of your prop test budget.
I can copy 2/3 of the budget. SpaceX Dragon, that completes the closure maneuver.
We copy. Closure maneuver complete.
That will move on to 4.041, section 4.
We copy and concur.
All right, so our manual flight test has been completed. We're standing by for them to now resume approach 1. So to move in from that waypoint 1, we're already inside of the keep out sphere at this point. Dragon's holding just 176 meters from the space station, and pretty soon they're going to be approaching.
Dragon, that completes the manual piloting demonstration. I only had to twist Doug's arm for 2 or 3 minutes to get him to allow me to deactivate the piloting controls.
We copy. Excellent. Thank you. And with that, we ask that you, from the display used for manual piloting, please go to audio settings and adjust a gain setting for seat 1 or 4. And in addition, we would appreciate any handling qualities evaluation of the proximity piloting possible.
We've completed the gain setting adjustment for seat 1, and I'll turn it over to Doug for the handling qualities quick look.
SpaceX Dragon on the big loop for the handling qualities. It flew just about like the sim, so my congratulations to the folks in Hawthorne. Flew really well, very crisp. It was a little sloppier and wide, just like we saw in the sim, but all the other axes, as well as closure and opening, were all just as per.
Excellent to hear. Thank you.
That kind of gives you an indication of sort of how the design process works. You know, Bob and Doug have had lots of opportunities to test this out and sim it and give their feedback. And pretty cool to hear that their sim experience was very similar to what they saw actually on orbit. Just, I think you said 170 meters away from station right now?
Yeah, we're just 176, and I imagine as a spacecraft designer, that's exactly what you want to hear, is the way that I trained you in it here on the ground is exactly how it performed once you're there for the real thing. So the second manual piloting test in the books, Bob and Doug putting Dragon through its paces. Now we're time to put it all to where we get to our endpoint. We're ready to get Dragon docked to the International Space Station.
Dragon SpaceX on Big Loop. The ground will be resuming approach shortly. We do plan to hold briefly at waypoint 2, so reminder that crew visors down are not required until the ground is preparing to command the final approach.
SpaceX Dragon, we copy. We'll hold at waypoint 2 for a pause, and then we'll get our visors then once you command.
We copy.
And station, it's Houston on the Big Loop. As you've heard, Endeavour is resuming its approach to waypoint 2. Chris, you can monitor now for step 2. That's step 2 and 1.104, Crew Dragon approach and retreat monitor.
Copy, step 2 and work.
Pretty cool view of the International Space Station from Dragon. This would actually be overlaid, or rather their controls would be overlaid on the displays on top of this view. And we got to see some pretty cool views from behind. Actually, there's a view right there. You can see the station on their displays. Visors up, Doug in the left seat, Bob in the right seat.
Yeah, so at this moment, Dragon is going to be resuming the approach. As we heard them informing the crew, they're going to have that one final hold when they're just 20 meters away. That's going to be at waypoint 2. We're expecting it to be a brief hold while the teams all tag up and do a final go to move in for docking. Getting a great look at the space station itself. The docking port is right in the center of our screen. You can see another spacecraft currently docked to the space station, the Japanese HTV spacecraft currently docked to the Earth-facing port, one of those common berthing mechanisms also on Node 2. So Dragon will be the second vehicle to be docked to the Harmony module once it makes its final approach. And it's moving in right now. Again, just to give you an idea of how quickly they're moving, they're going at about 0.3 of a meter per second right now. And so if you're having any trouble with that docking simulator online, remember to just slow things down a little bit and your chances will go up exponentially. We just passed 140 meters away. We'll get our live video comm back with the space station momentarily. As soon as we do, we'll bring you back up there. But for now, Bob and Doug continuing to fly in. They're just 135 meters away.
Station on the Big Loop. In step 2, review of steps 3 and 4 is complete. Crew on the International Space Station is ready for docking.
Station Houston on the Big Loop, we copy the review of 3 and 4 complete. International Space Station ready, thank you.
Expedition 63 Commander Chris Cassidy giving the report. Station is ready for docking.
Yeah, and you can see the trajectory of the spacecraft. There are small corrections that are happening. So as we get closer and closer to station, we're trying to stay within those two corridors, which are shown coming out of the docking port that we're going towards. That little dot, I think, was the 20-meter hold point, so that's where we expect there to be the spacecraft holding right in front of the International Docking Adapter. There'll be a go, no-go pole. The ground teams have worked hard over the past probably years to come up with a set of what we call flight rules. So those are technical constraints, items that we look for, that if any of those criteria were violated, then we have a rule that we've predetermined, gives us guidance to say whether we could approach or not. So far, our vehicle has been very healthy, but technical ground teams will all do their due diligence to make sure that it's still safe to approach.
Right, and at this moment, that approach is continuing, still moving in at about 0.3 of a meter per second. Dragon's coming up on just 100 meters away from the space station.
So the very top there is the nose cone on the spacecraft, where we've got a cool view. Left side of your screen is the International Space Station. Right side of your screen is Dragon.
We're inside 100 meters, continuing to close. Again, we're going to have a short hold at 20 meters. Teams will just do a final check, and then they'll give Dragon the go. We're expecting it to be pretty brief. We should get to that hold point in just about 4 minutes, moving at our current pace.
I think you can see a meatball and American flag on that on the spacecraft. The NASA logo, of course, referred to as the meatball. I think there was some spirited discussion about the meatball versus the worm during ascent. And you can see those logos. That structure on the fairing structure is actually what the Super Dracos are housed in. Of course, all of those are deactivated now, only used for launch escape during the ascent portion. Nose cone right at the top of the vehicle. And you can see sort of the sealing surface, those four circular slots right underneath the nose cone within that red ring are the forward bulkhead Dracos. That's what we were using while we were conducting all those burns, the 5 burns to get to this point. Right now, we don't have a reason to use those. We'll only be making small attitude corrections with the service section Dracos. And you can see the service section actually pretty clearly here too. There's a black portion and a white portion sort of separated by a fin. The black portion is solar panels, solar cells that'll charge Dragon's batteries. And the bottom side, the white portion, is actually a thermal radiator that's used to keep the spacecraft nice and cool. Of course, the avionics and the cabin, making sure that Bob and Doug are comfortable inside.
Looks like we're getting a shadow cast. We are just 60 meters away, continuing to close in, just about 40 meters to go until we're at that hold point. Should get there in just over 2 minutes. Meanwhile, teams in Hawthorne and in Houston doing their internal go, no go for docking. They're going to get all the teams pulled. Once everyone's go, we'll be able to give Dragon the final go-ahead for the vehicle to autonomously fly in and dock with the International Space Station. Should be coming up on waypoint 2 arrival in just about 1 minute, 45 seconds. At this point, it'll be 20 meters away from that docking port. The International Docking Adapter number 2 attached to pressurized mating adapter number 2 at the very forward end of the Harmony module.
Right there on the right around the center, you can see the forward hatch. It's got a window in it. You can see a couple of handles, and there's some features that look sort of bronze-ish. Those are the pedals that we were talking about earlier as part of the soft capture system. So pretty wild too to see. We're so close that we're getting shadows from the station on Dragon. Wow.
And we're getting these views of Dragon's approach from 2 cameras that are right next to that docking adapter. And the movement's a little jarring at times. These cameras are being commanded by a person at the Cronus console in Mission Control Houston, and they send some very basic function commands to the camera, which it then executes automatically. And so they're continuing to follow Dragon in, so we do thank them for their diligence to give us these views of this historic moment as we are just less than 30 meters away from docking.
Right above the NASA meatball logo, you can see three of the service section Draco thrusters.
That's right, 12 in all. So the 4 of those clusters spread around the vehicle, used for a lot of the attitude control and any small translational maneuvers like we just watched Bob and Doug execute with their second manual flight test.
Yeah, and actually oriented in a way, too, where if you were to lose some of those thrusters, you still have redundancy and control in those axes. That's part of the reason why they're sort of at the angles that they are.
All right, so we should be getting to waypoint 2 right now. And so it looks like we do have that hold.
SpaceX on Big Loop. The ground is go for approach 2. We will be enabling the resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside, the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
Copies all on the Big Loop. Go for docking.
So Doug on the spacecraft confirming their go for docking. They're going to put down their visors. Got some instructions there about the crew hands-off point that we had talked about earlier. That's a point where we don't want the crew issuing any commands to the vehicle. It's about just about 2 meters away from the docking adapter. I believe the number is about 1.7 meters.
Station Houston on the Big Loop. Houston and station are now go for docking. Chris, you can monitor per steps 3 and 4. 3 and 4 in 1.104 Crew Dragon approach and retreat monitoring.
Copy steps 3 and 4.
Next Dragon on the Big Loop. Our visors are down.
Copy, visors down.
With the crew confirming their visors down, we should see the final approach resume.
Station Dragon on the Big Loop. We are inbound from approach 2.
Copy, inbound.
Station copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so. Right before we get that final docking, it comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late. And so any aborts would be executed automatically by Dragon itself. So we're closing in at less than 1/10 of a meter per second at this point.
You can see the service section Dracos just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA2. It's the International Docking Adapter. You can see much more clearly there the hinge mechanism for the nose cone. Those 4 black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system. Wow.
Dragon on the Big Loop. We're inside 10 meters. We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
Right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute, 45 seconds away from docking.
There's a center line camera right in that middle, so that you can see where the forward hatch is, and right in the middle of that there's a window, and there's a center line camera that is aligned with the center of the vehicle and the center of the docking mechanism. So that is what the autonomous docking system is using to line up with sort of a cross-hatch, cross-target on the docking port. Again, the forward docking port on PMA2, or the pressurized mating adapter.
And we are just 5 meters away. Again, we're racing that sunset. This Dragon continues to close, 4 meters to go.
Those shadows of the space station on the vehicle. Yeah, you can actually see the centerline camera pretty clearly there, sort of with the contrast of the sun right now.
3 meters to go. Two meters. We are inside the hands-off point, the chop, the crew hands-off point. 1 meter to go. Soft capture complete.
Dragon in space. Soft capture confirmed. Stand by for retraction and docking.
And we just heard it, soft capture. We have docking, that coming at 7:16 a.m. Pacific time, with the station and Dragon flying 262 statute miles right over the border between northern China and Mongolia.
You saw a little bit of motion there of Dragon. That was that relative motion that the soft capture system is damping out. Once that motion is clear, then the soft capture system will be retracted, and Dragon will go for hard capture.
Again, if just now tuning in, that soft capture, that docking coming 7:16 a.m. Pacific, 10:16 a.m. over on the East Coast. Dragon and the International Space Station were flying 262 statute miles right over the border between northern China and Mongolia. So that soft capture ring now going to retract. It's one more step on the way to docking complete.
Yeah, please on board.
Yeah, and so the next step here is once the soft capture ring is retracted, there are 12 latches that we refer to as hard capture latches. Those are what will really create that pressure tight seal between the Dragon spacecraft and the International Space Station. So once soft capture is complete, and I believe we'll get that call from our core here, Anna, then we'll get confirmation of hard capture, and the crew, of course, aboard have this information on their displays, so they'll also see indication of hard capture complete. And once those two steps are done, then that's docking complete.
That's right, and we're expecting to hear some words from everybody. A pretty monumental moment. I mean, for Doug Hurley, he's returning to where he last docked almost 9 years ago on the very last space shuttle mission, now commanding the very first commercial spacecraft to deliver astronauts to the International Space Station.
That's got to be cool for them. They've mentioned quite a few times that they're best friends, our favorite dads in space, as we've been calling them. This has got to be really cool for them. It's got to be really cool for their families too, watching this.
Looks like we have another quick handover. We'll get that video back shortly. We're about 75% complete already with that retraction. Once that retraction is completed, we'll keep an eye out for the 12 ready to hook indicators. Once those are ready, those 12 hooks will begin to engage, and that'll securely attach Dragon to the International Space Station.
Yeah, so right now the vehicle confirming that the soft capture system is deployed correctly and is fully retracted. And then once the soft capture system is fully retracted, that'll set up the vehicle to put in the hard capture pins. There's 12 of those around the docking ring, and that's what creates that airtight seal between the Dragon spacecraft and the International Space Station. The volume between, which we refer to as the vestibule, is currently not pressurized. Of course, it was just exposed to the vacuum of space until literally minutes ago, about 4 minutes ago. So just waiting for the vehicle to get that.
Dragon SpaceX, ring retraction complete. Docking sequence is holding for MCS reconfiguration.
All right, so we see those ready to hook indicators are lighting up green. So we should be just about to step into those 12 hooks beginning to engage to get that secure mate between Dragon and the International Docking Adapter on the space station.
Wow, right now those two vehicles are flying together. They are attached to each other.
It's been just under 19 hours since we lifted off. We're actually at about 18 hours, 58 minutes, and 42 seconds. So we promised about a 19-hour ride up to station, and we made it just a few minutes before that. They were able to dock a few minutes ahead of schedule. We were tracking them to still take about another 10 minutes, but able to step through all of their burns about 16 minutes ahead of schedule and get us to where we are now. If you missed it just a few moments ago, that initial docking coming at 7:16 a.m. Pacific, 10:16 a.m. over on the east coast of the United States, and they were 262 statute miles flying together over the northern border of China and Mongolia. So really exciting. We're just waiting for this docking complete to be confirmed. We'll expecting to hear some words, obviously, from the crew on board and all the excited teams down here. We're just waiting for this moment. And then it's time to start getting Dragon integrated into the station. There will be an umbilical that will get mated, and that'll allow Dragon to flow data and power into the station systems, and then it'll be over to the crew.
Endeavour and station at Houston on the big loop. MCS is configured. We're proceeding with hook driving.
All right, and they did a quick, so the motion control system onboard station now back under those control moment gyros, so handed over from the Russian thrusters, and Dragon now given the go to drive those hooks. We have to do that changeover of attitude control before we drive those hooks, as the Russian thrusters a little bit more dynamic in their control of attitude, and if you had a thruster firing while you were starting to drive those hooks, that could miss a line. So going over to the smoother control moment gyros on the U.S. side, now controlling the attitude on board the station, and those hooks, those 12 hooks on Dragon, about to start driving.
Right now, Dragon and ISS attached, just flying off the east coast of China, just underneath Japan. Attached to each other, we recently passed over to the orbital night, so we're on the currently the dark side of the world. And actually, we're lucky enough to see the soft capture happen just as we were crossing over the Terminator line.
And if you're wondering what you're looking at, this is one of the cameras on the very outboard part of the Japanese experiment module, looking back in towards the very front part of Node 2, where Dragon is currently docked. We are in an orbital nighttime, that's why everything is so dark, but you're looking at Dragon. It is horizontal to the ground. So the hatch part is right where that green light pretty much is. You can see the nose cone still illuminated above it, and it is currently attached to an international docking adapter on the International Space Station.
And inside that capsule are Bob Behnken and Doug Hurley, first astronauts to fly on a privately developed vehicle up to the International Space Station. Both test pilots got to do some fun tests today. Have a few more steps before they can actually get aboard and ingress to the International Space Station. And that's what we heard over the big loop, that transition which allows us to then proceed with hard capture.
And we're seeing the first set of hooks, so the first 6 out of the 12 are now closed, 6 more to go.
Again, there are 12 of those along the ring. And that helps us ensure that we have an airtight seal. It is vacuum around them right now, so we want to make sure we're keeping all of that valuable life support in the vehicle. Now the combined ISS Dragon vehicle.
Meanwhile, inside the capsule, Bob and Doug also standing by for this hard capture to complete. And once we have that docking complete call, they'll be able to start stepping through a number of procedures to get them ready to move into the International Space Station. They'll get the go-ahead to doff or get out of their suits, and then they'll have some activities on the Dragon side to prepare for the hatch opening. Chris Cassidy will mainly be working on the station side to pressurize the vestibule. So as Shiv has talked about, the space between the Dragon capsule and the space station was exposed to vacuum, and even after this tight seal has occurred, we'll still be at vacuum inside. So we'll actually open up a valve to supply air from the station side into that space between the Dragon and station hatchways, and they'll get it up to the same ambient pressure that we'll have inside of Dragon and on the station itself. They'll wait for it to thermally balance out, make sure we don't have any temperature swings as we're bringing it up from vacuum. So probably from a very cold temperature up to about 72 degrees that they have in their cabin temperature on board the station. And then we'll get the hatches open.
Dragon SpaceX, hard capture complete. Stand by for docking completion.
Copy.
Now that hard capture is complete, so that's confirmation of those 12 latches to create that airtight seal. Now that's complete, the umbilicals from the station side will interface with the Dragon vehicle umbilicals, and that'll provide power and communications through space station directly to Dragon. Pretty much the whole way up, Dragon's been using a combination of batteries and its solar cells pointed at the sun to make sure that it has enough electrical power for the journey up.
And we're just standing by now for that umbilical to get mated, and that's going to, again, as Shiv was just saying, start the power and data transfer between Dragon and the space station. They've been transmitting data through RF radio frequency on the way uphill, and during the final approach, this will give a hard mate, basically a wired LAN connection between the Dragon spacecraft and the International Space Station itself, and then also being able to draw power from the station systems using those great big solar arrays that are used to generate all of the electricity for systems on board the station. The soft capture system has been stowed. We see the umbilical starting to deploy. About 40% of the way so far, going pretty quickly. Should just take a couple more seconds until we're all the way connected. And then we should be getting that docking complete call out from the Corps here in Mission Control, SpaceX and Hawthorne. Standing by.
Dragon SpaceX docking sequence is complete.
SpaceX Dragon, we copy docking complete. To say that it's been a real honor to be just a small part of this 9-year endeavor since the last time the United States spaceship had docked with the International Space Station. We have to congratulate the men and women of SpaceX at Hawthorne, McGregor, and at Kennedy Space Center. Their incredible efforts over the last several years to make this possible cannot go overstated. I'd also like to thank Kathy Leaders and her team of the Commercial Crew Program of NASA. An outstanding job by everyone. Last, I'd like to thank the men and women of the National Aeronautics and Space Agency. This is an incredible time to be at NASA. 3 new vehicles to be flown, continuing mission in low Earth orbit, and then to the moon and Mars. We thank you again and congratulate you.
Dragon arriving. Crew of Expedition 63 is honored to welcome Dragon and the Commercial Crew Program to welcome aboard the International Space Station. Bob and Doug, glad to have you as part of the crew. Well done. Bravo Zulu.
Kathy. Thank you, Chris.
Thank you, Chris.
Endeavour, this is Houston. Bob and Doug, welcome to the International Space Station after your spectacular rendezvous and docking of the first Crew Dragon vehicle. For the first time since the retirement of the space shuttle, you have completed a historic ride to the ISS and have opened up a new chapter in human space exploration. On behalf of the flight control teams here in Houston and in Hawthorne, California, and to our SpaceX colleagues, bravo on a magnificent moment in spaceflight history and on the start of a new journey that has changed the face of space travel in this new era of space transportation. Bob and Doug, good luck, and we look forward to working with you on board.
Dragon SpaceX, Bob and Doug, we here at SpaceX are honored to have been part of ushering in this new era of human spaceflight. On behalf of the SpaceX and NASA partnership, congratulations on a phenomenal accomplishment and welcome to the International Space Station.
Well, thank you, Anna. We appreciate all the good words and everyone thanking us, but it truly was a magnificent effort by the entire team, the SpaceX team, the NASA team, and a team across America who was able to pull this off and bring human spaceflight again to our nation. Thanks for everything. Happy to be aboard.
And Dragon SpaceX, with that, ground will be enabling hardline power and comm connection shortly. You are go to doff your suits per procedure 4.012. We will be configuring your video to go external shortly, and we have one request for Bob's suit doffing when you're ready to copy.
We copy all. Go ahead for Bob's suit.
During your approach suit leak check, we noticed Bob's suit pass with a lower PSID than his previous vehicle and O&C checks. We still had plenty of margin to support you in a depress, but in order to rule out potential hardware issues, When Bob is doffing, after he opens his structural zipper, check all 3 bladder zipper heads to see if any are partially closed. It is possible that if the head is backed off slightly, that the white tooth is partially visible or a small gap can be seen between the end of the zipper head and the gasket end. Please report observations.
Copy. Bob will take a close look at his zippers when he doffs, and he'll get doffing first, so we'll let you know as soon as we see something or if we see something.
Great. Thank you so much.
Wow. So now Dragon has completed its docking sequence. There's a number of checks. That was an absolutely historic moment. And in spite of that, the ground team's getting right back to business, talking about the suit performance.
Just let us know when the interior cameras are secured.
On Dragon to ground,
Gotta turn the cameras off first before we can get them out of their suits.
Absolutely. So spacecraft is now docked. They've got several tasks that they're going to need to be able to do. While we're waiting for those tasks to happen, we're actually going to take a short break. But if, in case you just missed it, the Dragon spacecraft is now docked to the International Space Station, docked at 7:16 a.m. local time.
Yep.
Bob and Doug are at the space station.
Yeah, they're there. It was just under a 19-hour journey from their launch to their docking, so pretty much right on what we were expecting. They got there a little bit early today, which was nice, as they were able to get through all those burns. But they're docked. It's going to be a little while. They have to do that vestibule pressurization, and then they'll have to do some leak checks.
Dragon on Dragon to ground for Bob. I've got both structural zippers on my gloves lowered, and I do see white teeth visible on both sides. It looks like a full white tooth. I'll give you an update once I get to the leg zipper.
Copy. White teeth on both sides, and we'll await your next status.
So the crew right now just going through some checks of their gloves. They're about to get out of their suits. That'll be the first step for the crew on board Dragon. For the crew on board station, Chris Cassidy is going to start getting that vestibule pressurized, and then they're going to do leak checks. So they're going to be actually taking atmosphere from station, putting it into that vestibule, and then once we get all the leak checks done, things are thermally stabilized, it'll be time for hatch opening. We'll be able to see Bob and Doug get into the space station for the first time from on board the Dragon spacecraft. And again, for Doug Hurley, this is the exact port he was at almost 9 years ago when he was on the very last space shuttle mission, and now he's commanding the first commercial vehicle to dock with the International Space Station. I think that's going to do it for us in Hawthorne. We're going to give you into the very capable hands of Gary Jordan to take you through the rest of the hatch opening. We're going to be watching from here and following along. We can't wait to see these crew members on board the International Space Station. Thank you for everybody who tuned in. We hope you enjoyed the launch. We hope you enjoyed the ride uphill. We really hope you were with us every single moment from suit up until now, so you've been up for over 24 hours. But it's been an incredible experience for us to see these guys get on board the International Space Station, to watch Dragon go through the paces, to be lofted into orbit on Falcon 9, something we've been waiting for years, seeing it come to fruition. I'm still grappling with.
Dragon, SpaceX on Dragon
really
to ground.
Incredible.
Video is
and
no
Shiv,
interior.
It was an honor doing this with you today.
Yeah, absolutely, Dan.
Dragon copies. Thanks, Anna.
Can't step on the crew. That's the one rule.
Yeah.
But, there are some really great words there from all the flight control teams about how this was a joint partnership between NASA and SpaceX. I think everyone is over the moon here at SpaceX for this. Bob and Doug have got to be excited, and now back to business to get the vestibule ready to go, and then get them on board the station. So again, thank you for following us. Please continue to watch as Gary takes over for the hatch opening portion, and keep following our social media for more updates on what's happening with hatch open.
Over to you, Gary.
Thank you, Shiva. Thank you, Dan. What an incredible flight for Bob and Doug, lifting off just yesterday and now in space, attached to the International Space Station. Some kind words all over after docking at 9:16 a.m. Central, and a hard mate just 11 minutes later, We're still not done here. We're going to take you through the pressurization sequence and eventually hatch opening of the International Space Station.
SpaceX Dragon on Dragon to ground. Cabin mic check, com.
And I hear you loud and clear on Dragon to ground. How me?
Loud and clear.
Excellent.
Good comm checks. We still have a lot of work to do here. We're going to pressurize the vestibule and eventually get...
And SpaceX Dragon with an update from Bob. It looks like a white tooth on the leg zipper as well. We'll take a close look if we can see anything else that might have resulted in that lower leak check pressure.
Copy. Really appreciate the report. Thank you.
Teams behind me will be configuring the Dragon and the International Space Station to welcome Bob and Doug aboard. First, of course, the International Space Station attitude control moment gyros, really holding the Dragon in place through the hard capture sequence. We'll start enabling those thrusters and pressurizing the vestibule. It'll take about an hour until we're able to get the hatch open. The teams here in Mission Control Houston, Orbit 2, led by Flight Director Zeb Scoville, will be taking us through that process. Aboard the International Space Station, Commander Chris Cassidy standing by in Node 2. Right in front of that is the pressurized mating adapter. He recently opened up the hatch to introduce some of the station air and mix it, get a nice mix in there, avoiding some CO2 pockets. That hatch you see just beyond Chris Cassidy there is normally closed. He was able to open it a little bit earlier today, mix some of that cabin air, and get rid of those CO2 pockets, make sure it's all clean and ready for Bob and Doug. He closed it shortly after just to make sure no FOD or foreign objects, anything were to float in there that would inhibit any hatch opening process today. One of the next milestones for Chris Cassidy will be to open up that hatch. He's got some cameras you see placed within that node. We'll get some good views of the hatch opening and welcoming Bob and Doug here in just about an hour. A big moment in history today, May 31st, 2020. Just on the other side of that hatch, Bob Behnken and Doug Hurley have successfully arrived at the International Space Station. Still a couple of milestones to get through before we can open up that hatch. It's going to take some time. First, pressurizing the vestibule in between the station and Dragon. We'll bring that up to pressure. It's going to take some time for that pressure to stabilize. Of course, the temperature within that vestibule causes a little bit of swing, so we'll just wait for that to pressurize or to stabilize before opening up that hatch. Here at Mission Control Houston, Flight Director Zeb Scoville welcoming the director of the NASA Johnson Space Center, Mark Geyer. We'll have a few other VIPs here in the room to welcome Bob and Doug once they get through that hatch. Now again, this repressurization and hatch opening process is going to take some time. You see now we're going to have some intermittent losses with the communication from the International Space Station. You're seeing now the International Space Station Flight Control Room led by Flight Director Zeb Scoville. Just a handover of some of those audio and visual communications. We'll be regaining those shortly. Might lose them intermittently throughout the repressurization process, but the teams here will be monitoring all of the procedures again, pressurizing that vestibule and eventually getting to that hatch opening. From right to left there, seated, you see Flight Director Zeb Scoville. It was he who was leading the teams for both the launch of Bob and Doug over at the Cape. He was leading the teams here in Mission Control Houston. You just saw the Johnson Space Center Director Mark Geyer walk off to the side. Seated next to Zeb Scoville, Joshua Kutrick. He is one of the members of the most recent class of astronauts, the class of 2017. Canadian Space Agency astronaut, went through candidate training and officially became an astronaut just recently. Again, a few milestones to get through to that hatch opening. First, the International Space Station attitude control has been successfully switched from control moment gyro only control, enabling some of the thrusters on the International Space Station. We also just received word that Dragon is successfully receiving power.
Ground ISS power connection has been established.
And there you have it. Dragon is successfully receiving power from the International Space Station.
And Dragon copies on Dragon to ground that power has been established. Just let us know when we should make a hardline comm check.
We will, Co. Thank you.
For those of you just joining us, you are getting a live look at NASA astronaut Chris Cassidy, commander of the International Space Station, doing some of the prep work to open up the hatch and get ready to welcome Bob Behnken and Doug Hurley aboard the International Space Station. They launched successfully yesterday at 2:22 p.m. Central Time, 3:22 p.m. Eastern, and docked successfully with a contact and capture just a little bit ago at 9:16 a.m. Central Time, 10:16 Eastern. Now, some of the milestones to get that hatch open have already taken place. First, attitude control. For some of the docking sequence, for the initial contact and capture, attitude control was on Russian thrusters. That was moved to control moment gyros for hard mate, making sure that everything lined up and we got those ready-to-hook indicators green before driving those hooks. The attitude control has since been switched to enable some thrusters on the International Space Station. We did get confirmation of good power being delivered from ISS to the Dragon. Next will be to test some hard line communication between Dragon and the International Space Station.
Dragon and station. It's Houston calling on the big loop. We're prepared and getting ready to transition the comm system to hardline, at which time we're going to do a couple comm checks. We just want to make sure everybody's on board with that and aware. So Dragon first, maybe let me know if you hear this and if you're go with that plan.
Yeah, Houston, Endeavor on the big loop. We had you loud and clear.
Houston Station copies and concurs.
Okay, Endeavor and Station, we have you loud and clear on RF right now. We are putting it in work now, so transitioning comm system to hardline, and we'll call you back for voice checks momentarily.
Endeavor copies.
This is Mission Control Houston. The voice you just heard was Capcom Joshua Kutrick from here in Mission Control Houston, relaying through the big loop that's integrated communications with Dragon and the International Space Station, just taking us through those procedures until we get to hatch opening. Now there's an umbilical connection with Dragon, connecting Dragon to the International Space Station. We did get good confirmation that power is flowing from the International Space Station to Dragon. Next, we'll be proceeding with some of the communications checks. The big loop established on the C2V2 Common Communications for Visiting Vehicle through some of the last legs of the rendezvous and docking of Dragon to the International Space Station. We'll switch that over to hardline communications, testing that out here shortly. we're going to get some good views of station today. You see Chris Cassidy working inside Node 2. Just on the other side is the hatch. That hatch is separating between the International Space Station and the pressurized mating adapter. One more hatch to go after that. That hatch opens up to the Dragon hatch with Bob Behnken and Doug Hurley on the other side. Just surrounding Chris Cassidy from this view, you can see a series of cameras. We're going to get some great views from Node 2 there on the left, a couple high-definition cameras. On the right, a 360 VR camera. Part of an initiative to engage viewers and provide views that from the International Space Station that have never been seen before. We'll get to see some of those 360-degree views later after they're configured and stitched on the ground, now being recorded during this historic moment today, May 31st, 2020.
Affirmative, we are on the same page. Those steps in the execution note are all that's needed.
In work.